Hi, in this video we're going to talk about multiplying and dividing rational expressions. So let's take a look at the first example. 14x squared over 5 times 10 over 21x squared. You should have, hopefully by now, a pretty good understanding how to multiply fractions and how to simplify fractions. So we're going to rely on this concept. The first thing we normally want to look at is see what quantities on top can be divided with what quantities on the bottom. So clearly see 10 and 5. So we divide that, that's going to leave us with 2, that's going to leave us with 1. Let's take a look at these two. So there's x here and x squared here, so this x cancels with one of those. And then you also have 14 and 21. They both divide by 7. So 14 divided by 7 gives you 2. 21 divided by 7 gives you 3. So all that is going to leave us with 2 times 2, that's 4. We also have x, 1x left, and 3 on the bottom. Okay. Example 2, do the same thing. We're going to look at this and see if there's anything we can simplify. So 6 over 2, obviously both divide by 2, that leaves you with 1, that leaves you with 3. There's nothing else we can do here because the quantity x and the quantity x minus 2 do not have any common factors. So we're just going to write 3x divided by x minus 2. Example 3. So here we are going to do the following. The first thing we want to do is we can factor out 2 in the numerator here. So we are going to do that. 6 minus 1 over 5 times 15x divided by 4. And now we're going to try to simplify if there is anything. So we can clearly see 2 and 4, that's 1 and 2, and 15 and 5 gives you 3, leaves you with 1. Okay, so what do we have? We have 3x here. We also have this x minus 1 that we never did anything with, and we cannot do anything with that, and all divided by 2. A common question is, do we need to distribute this? It depends what the question is going to ask and what your teacher may expect. So it is possible that your final answer may be written in the form 3x squared minus 3 divided by 2. Next problem. So we always want to look at these problems, especially the more complicated ones, see if there is anything that can be factored. So we got x plus 3 over 8, nothing can be done here. We got 4 over, now here we can factor out x. So we take out x, that's going to leave us with x plus 3. And now let's see what we can simplify. So 4 and 8 obviously. And then we have x plus 3 here and x plus 3 here as well. So we're going to cross those out and they are no longer there. So what do we have remaining on top? Just 1 times 1, which is 1. And on the bottom we're going to have 2 times 1 times x, and that's going to be 2x. Alright, moving on. Now we're going to talk about the division. So as you know, when you divide fractions, you do keep, change, flip. So you keep the first fraction, change this to multiplication, and flip the second fraction, right? It's reciprocal. So that's precisely how we're going to do it with rational expressions. So 12x over 5 times x plus 1 divided by 6x cubed. Okay, so now we're going to see what can be simplified. So we have 12 and 6. We have x here and x cubed here. So this x cancels and this is going to drop it by 1. So it's going to become x squared. So what do we have? The numerator will have 2 times x plus 1. And the denominator is going to have, oh, you know what, I made a mistake, I just realized that. Well, actually, you know what, we'll just fix it another way because I don't want to redo the whole thing. So let's just imagine this was 6. It was actually 16. It's my mistake, but I don't want to create a mess here now. So let's just say it was 6. Okay, so 6. Here we're going to have 2 times x plus 1, and on the bottom we're going to have 5 times 1 times x squared, so 5x squared. Next problem, first rewrite. 18 over 5x squared times 10x cubed divided by 9. Let's check, make sure I copied this correctly. Yes, I think I did. So 18 and 9. 5 here, 10 here. That's going to be 2, that's going to be 1. And we also have x squared here, and we have x cubed here. So there's a higher power here, and it's going to leave you with just 1x. So what are we left with? We are left with 2 times x on top. That's 4x. 1 on the bottom, or simply rewrite that as 4x. Next problem. Rewrite first. So we have x over x minus 1 times x minus 1 over x squared minus 3x. Now you don't have to do it in any particular order. You should factor this, but I see that I have x minus 1, and I'm going to cross those out. That's going to leave me with 1 here and 1 here. So when I rewrite that, I'm going to have x times 1 in the numerator and 1 times x squared minus 3x in the denominator. So am I done? No, because I can still factor this, and that's going to end up canceling with that x on top, because there is a greatest common factor x that I can take out. It's going to leave me with x minus 3 in parentheses. So the two x's that I have are going to cross out, and I'm going to be left with what? Now, this is why we always write 1, because a common mistake that students would make here, okay, I got nothing left on top, the answer is just going to be x minus 3. No, the answer is going to be 1 over x minus 3, because you have 1 left. Things don't really cancel when you divide, they may become 1. Okay, next problem. So let's rewrite first. 4x minus 8 over 5 times 13 divided by x minus 2. Nothing looks like we can cancel, so let's try to factor. So we can factor out 4 out of this. It's going to leave you with x minus 2 over 5, and here we're going to have 13 divided by x minus 2. X minus 2 and x minus 2 cancels. That removes all the x's from our expression, and we just write the remaining part, hopefully simplified. 4 times 13 is 52, and the denominator is going to have 5. Okay. So you already understand that many of these problems will require factoring, and that's precisely what we are going to do. So let's go ahead and do that. So we have a problem like this. Well, nothing seemed to cancel right now here, and we're just gonna have to factor first. It is multiplication, so we don't have to rewrite anything. So here we can take out a common factor of 2, which is gonna leave you with x plus 3. On the bottom we can take out a common factor of 5, which will leave you with x plus 2. The second fraction, we're gonna have x plus 2 here. There's nothing we can do with that. The denominator in the second fraction is going to be x plus 3 times x plus 1. This is how we can factor it. So, what can we do now? We can have x plus 3 on top and x plus 3 on the bottom. It's going to leave you with 1 and 1. X plus 2 and x plus 2, it's going to leave you with 1 and 1. Is there anything else we can do? Doesn't look like that. But remember, you can always rewrite what you did after all the things that you simplified, and see what else might need to be simplified. So nothing is necessarily final. But what do we get here? So the numerator 2 times 1 times 1, which is 2. The denominator is going to be 5. and we have this x plus 1 left here, and that's what our answer is going to be. Example 10. Nothing looks like we can, we don't see anything here that can cancel right now, so simplify. So we're going to factor 3 times x minus 2. There is a common factor of 3 that you can take out, divided by 2 times 5, and here we're going to have x minus 2 times x plus 2. The denominator of the second rational expression is difference of squares. And we have x minus 2 that we can divide. Okay. So let's rewrite. So 3 times 5 is 15. And in the denominator we're going to have 2 times x plus, oops, that was x plus 2. My mistake, x plus 2. You always want to check what you're doing. Sometimes you may look at one number and accidentally copy that, and then it causes mistakes. So always check your work. This was a good example here. Alright. And let's take a look at this problem. So now it's division. Since it's division, we're going to have to rewrite it first. So we're going to have x squared plus 5x minus 24 divided by 2x plus 2 times x squared minus 8x minus 9 divided by 3x plus 24. So now we can go ahead and factor. You actually can start factoring as you do that, or before you do that. It would not make much difference. I'm just showing you all this in a consistent form. So but you can factor before you do this. That's not really going to change anything. So when you factor this, hopefully you're familiar with factoring trinomials. It's going to be x squared, I'm sorry, that's going to be x, strike that, x plus 8 times x minus 3. The denominator you can factor out 2, which will leave you with x plus 1. The second rational expression, you can factor the numerator here as x minus 9 times x plus 1. The denominator you can factor out 3, which will leave you with x plus 8. And now we're going to go through everything and see what factors are going to divide. So x plus 1 and x plus 1, x plus 8 and x plus 8. I don't see anything else, but again, we will double check once we get to our next step. So x minus 3 is left, x minus 9 is left, and the denominator is going to have 2 times 3, which is 6. There is nothing else we can do here. Next problem. Let's rewrite first. Again, I'm trying to be consistent here. So let's go ahead and factor now. So the numerator of the first rational expression is going to be x minus 4 times x plus 3. The denominator you can factor out 3, which will leave you with x minus 3. Second one, 12 over x minus 4. You can't really do much here. It's nothing here is going to factor, but we have factor x minus 4 here and x minus 4. Those can divide. And we also have 12 and 3, which will leave you with 1, and this leaves you with 4 since they both divide by 3. And what do we have? We're going to have 4 times x plus 3. And in the denominator we're going to have x minus 3 remaining. Okay, I have one more example. So we have this example where I combine 3 of them, and I have multiplication and division. Please remember, multiplication and division can be performed at the same time. You just have to do it left to right. I don't really have to worry about this, but because I have the division afterwards, but we're still going to keep that in mind. So let's rewrite first, because we need to change this to multiplication. X squared minus 1 over 2x minus 4 times x squared minus 4 over x squared minus x minus 2 times 3x minus 6, we're flipping this one, over x squared plus x minus 2. Now we can go ahead and factor. So what do we have? Difference of squares, x minus 1 times x plus 1 over 2 times x minus 2. The next rational expression is x minus 2 times x plus 2 divided by x minus 2 times x plus 1 times, then we can factor out 3 here, which will leave you with x minus 2, and here we're going to have x plus 2 times x minus 1. So quite a bit. Let's go carefully through everything and make sure we don't miss anything and don't do anything crazy here. X minus 1 here and x minus 1 will divide. X plus 1 and x plus 1 will divide. That leaves you with 1 and 1 and 1 and 1. X minus 2 and x minus 2. X plus 2 and x plus 2. This x minus 2 and this x minus 2. It looks like all the factors that contain x ended up canceling. So what's left? The numerator 1 times 1 times 1 times 3 times 1, that's obviously 3. And the denominator is 2 times 1, 1, 1, 1, that's going to be 2. And it's going to be 3 halves. Okay, so I hope this was helpful.